So, for our first talk of this session, we've got Sophia, who will be sharing about her journey as a change maker. Sophia is a high school senior who has conducted research on environmental issues.
So I will be sharing my journey as a change maker. And the start of my journey was when I was going into high school, and I went on a family vacation and took a tour of the coral reefs through submarine. And I expected the coral reefs to look something like this, what we usually see in the movies, with a lot of color, a lot of life, and fishes swimming to different anemones. But instead, I was surprised to see something that looked like this. It was a site that was very bare of life, very monotone. And I was surprised as a young tween that was just going into high school. And I thought to myself, maybe there's something I can do about this. Obviously, it's a really big issue, but research is the stem of fusing creative ideas to actually solve greater problems that we're interested in. So, my school has a science research program, and I decided to take advantage of this and join in my freshman year of high school. And my first project was actually about coral reef regeneration by the studies of creating a sunscreen alternative. So, a surprising fact is that when we go swimming, the sunscreen rubs off our bodies, and there's some chemicals that sunscreen contains, such as titanium dioxide and oxybenzone, that actually seep off of our skin and make their way to coral reefs, where they display and kind of cause the effect that's seen in the second picture I just showed. So I look to cyanobacteria and the proteins that that has to replace these chemicals and try to innovate a sunscreen alternative. The next project that I did was creating a bioplastic that degrades itself out of styrofoam that created natural larvae frass. And I took a turn after this project to focus on a biomedical project that was less environmental but still super impactful that looked at gene identification in mixed lineage leukemia. After this, COVID began, and I could no longer work inside a lab. So I took on remote projects in an internship, and this was completely unique from others and broke a stereotype that I once thought research defined. So, kind of a misconception and stereotype about research is that researchers wear these white lab coats, they're in a lab, they have their goggles on, they're using a microscope, they're putting different substances into flasks and beakers and mixing them together. And actually, when you search up science research on Google, you look at the images, this is exactly what you'll find. But I, during my online kind of research with COVID, since with safety precautions we couldn't go into a lab, found that there's an entire new dimension to research, which is big data. So, first off, what is big data? Big data is a field that treats ways to analyze, systematically extract information from, or otherwise deal with data sets that are too large or complex for traditional computers to process. So, what this means is that big data scientists can mine through massive publicly available data sets with a bunch of data that, without analyzing it, there's no real meaning to it. And if we apply our own research questions to it, we can extract really impactful results. So, although this was intimidating to me at first because I was used to this whole white lab coat, goggles kind of research, I found that this new scientific field was really intriguing to me because it opened new doors of endless possibilities and can be done anywhere because as long as you have your computer and the apps that you need, such as RStudio and Python, you can conduct this kind of research. So, a quote that my math teacher this year actually shared with us that kind of relates to this and the creativity of big data is he was talking about textbooks. We shouldn't read our textbooks, we should fight them. We should ask them our own questions and look for our own examples and discover our own proofs. So, how does this relate to big data? When kind of analyzing the big data sets that we're given, we shouldn't just read through them and look at the data because we're not going to find meaningful results. We should kind of fight them and ask them our own inquiries and challenges and extract our own deeper meanings and contextual interpretations to take out some kind of result out of the seemingly random noise. So when we have our own research questions that are super specific and we apply them to the data sets that we find, we can really make impactful results. So I'm going to use one of my projects in specific that I conducted this past summer, and it's about assessing land trade-offs between a 100% renewable energy and global agricultural system. So renewable energy is really important because with climate change, we want to cut down on the use of fossil fuels for the energy industry because that creates greenhouse gas emissions, which are really toxic to the environment, and focus on renewable energy. Another thing that is a basic necessity alongside energy is food. And right now, the Earth has 29% land, 71% is habitable, and 50% of this land that we can develop on or is habitable is used for agriculture. But still, nearly a billion people across the world experience food insecurity. So, because we use so much land already for agriculture, and still so many people do not have adequate access to food sustenance, we have to increase land productivity and greater sustainability for food to make sure that people, especially in developing countries, have the correct access. Now, where do renewable energy and food kind of come into play together? Well, we have only a certain amount of available land left to develop on, but we have to maintain the agricultural needs, but also the energy needs of the people. And both of these things take up a lot of land. So, my research project talked about how we currently have a lot of studies that evaluate the plausibility of the 100% renewable energy plan transition. So, going from the current energy system to renewable energy, but it lacks this correlation between renewable energy transition to agriculture and the food supply. So the goal of my research was to kind of distribute land in different countries and analyze land trade-offs in places where there's really high productivity to develop agriculture, but also really high productivity to develop renewable energy in overlapping places, and kind of deciding, okay, well, there's really high productivity to develop both, but not both of them can be developed in the same piece of land. So which one's going to have the greater yield to support the surrounding community, especially in developing areas where they already lack supplies and resources? And I assessed this by stimulating projections and visualizations to distribute land according to the current demands. So these were a couple maps that I created using big data, and I took data sets that were really large, but kind of assessed them in my own way by finding the productivity and then coding and going through multiple steps to create these graphs using big data, especially in processes that are in RStudio. And out of these graphs, I created a top 50 future focus countries. So looking at the amount of wheat or agriculture that is produced in a country, and if we prioritize agriculture, how much renewable energy will then be lost? So in countries in Table A, where we prioritize agriculture and lose very little renewable energy opportunities, it's okay to prioritize agriculture because not that much renewable energy opportunities are lost. However, in graph B, I found that when we prioritize agriculture, there's a lot, and the numbers are extensively greater for the amounts of renewable energy lost. So, kind of providing an outline to future scientists to show that, okay, these are the countries here that should be used in part B for renewable energy, and these are the countries here that we should really focus on agriculture to maintain the sustenance and sustainability of these resources to the people. So these are some references in the slides, but to conclude, I just want to reiterate that there's so many dimensions to research, and when we research, there's the traditional white lab coat setting, but there's also this kind of big data research that can be done from anywhere, and using big data to find conclusions that support things that are scientific, but also relate to major social issues if that's what you're interested in. And there's so many types of research that you wouldn't even imagine. So if you have any type of research question, you can pursue that. I know someone who researched going to different concerts, and they were in the audience and just researched the human behavior of the other people at the concert. So their research was just going to concerts and taking notes, basically. So whatever questions you have, you can address them through research in your own creative way. And whatever you're interested in, you can pursue. no matter what dimension of research it's in. And if anyone has any questions, I'd be open to take any if we have time.